Hi, my name is K. Scott Rowe. I'm a sysadmin for the National Radio Astronomy Observatory. The picture here you're seeing is of the Carl G. Jansky Very Large Array. This is one of our instruments that Eric Wilcox mentioned this morning. And he also mentioned it's a radio interferometer of 27 25-meter dishes operating at centimeter wavelengths and generating about a terabyte of data per day that needs to go into a permanent archive. You may have seen the VLA in such famous films as Contact 2010 or Terminator Salvation. And I'm going to talk to you about an implementation we made of a transfer plugin in HTCondor we call nraorsync. So some of you may know this, some of you may not. HTCondor comes with a file transfer mechanism. This is the system that copies files for you. It downloads input data to and uploads output data from an execution host. And one of the big things about it is it allows you to use local storage. You enable it, which should transfer files equals yes, and you use the commands transfer input files and transfer output files in hopefully obvious ways. What you might not know is that there's a plugin system to the file transfer mechanism, which allows you to write a plugin to copy files the way you want. You can see examples of it in user libexecCondor. Anything with an unbar plugin is probably a plugin. There are versions there for box.com, Google Drive, Microsoft's OneDrive, a few others. And the way Condor knows which plugin to use is it will run each of these plugins with a -class add option to see what support methods they handle. For example, ours says it supports nraorsync, which then equates to a scheme like nraorsync://. So any file you're asking to transfer that has that scheme in it, Condor will know which plugin to use. So why do we want to use a plugin? Well, here we have NVMe drives on our execution points, and we'd like to use that for processing instead of our shared Lustre storage. Also, our input data can be quite large, hundreds of gigabytes, and the output data can be sometimes even larger. We tend to launch jobs in batches, so we'll launch dozens at a time, maybe more. The file transfer mechanism doesn't allow you to choose which NIC to use. So your execution point may have 1 gigabit, 40 gigabit InfiniBand, it may have a 10 gigabit, it may have other interfaces. The file transfer mechanism doesn't let you choose which interface you want to use. It also uses the access point, the submission host that you submitted the job from for data transfer. So you put all this together and we were flooding the NIC, the default NIC on our access point. Other users were seeing slowdowns, they were having trouble logging in, all this sort of stuff, because it was so busy transferring all this data all the time. And finally, we also wanted to use rsync. Since our data sets get so large, we would like to use rsync to only upload what's changed instead of uploading the whole thing at the end of the job. So that and a little bit of curiosity about this whole plugin mechanism, we decided to write a plugin, and we created a data mover host, which I'll explain here in this very cheesy diagram of the networking into Mexico. And I'll go over 3 cases here that are common that might explain this whole situation. So over here on the bottom left, we have our NRAO cluster. This is our on-premises cluster. It mounts Lustre over InfiniBand, so that's a relatively fast connection. But when you use the file transfer mechanism, it will use this 1 gigabit link. Hopefully you can see my mouse here. It will use this 1 gigabit link to the access point. That's not ideal. Another case is we have a cluster across the street at our hosting institution, New Mexico Tech. It does not mount Lustre. But again, the file transfer mechanism will want to use the 1 gigabit interface to our access point. We would rather use this 10 gigabit interface to our data mover, which then gets things over InfiniBand. The third case is pretty rare, but we might have something out on the internet, something running at CHTC, something not on our controlled system. And we would again like it to go to this 10 gigabit interface to our data mover instead of defaulting to the access point, which sadly isn't drawn here, but does have a 1 gigabit connection. So how does this plugin work? So HTCondor, turns out, will transfer all files that don't need a plugin first. Then once it's done with that, it will transfer all the files that do need a plugin. For example, for transfer input files, the first thing it will do is it transfers this SSH key because it is not asking for a plugin, it's just a file. And then using that SSH key, our plugin can then use rsync to get this input data using the NRAO rsync plugin. And Condor knows to do this because it has this scheme. It looks like a URL with NRAO rsync instead of HTTP or what have you. Next, we set a custom attribute called nrao transfer host. This basically just, the plugin reads this and it decides how to rsync data depending on what's it set. If we set it to local, then it knows that we must be on our on-prem cluster and it can mount InfiniBand, or it can mount Lustre over InfiniBand, and therefore it can just use source and destination paths just like a regular rsync user would. If it's set to some host name, then it will try and use that. For example, Gibson here is our data mover host. And this is Gibson 10G2 is our 10 gigabit interface to that data mover host. So if it sees a host name, then it will know to rsync using that host name. And finally, if it's undefined, then it will just, the plugin just defaults to the internet addressable address for our data mover host, which is just Gibson. It'll just get it over the internet. And then we set output destination equal to nrao rsync some directory. And again, that nrao rsync scheme tells Condor to use the plugin nrao rsync anytime it outputs or uploads any files. So what problems did we run into? We ran into a few. The biggest problem we had was with transfer output files. We wanted to use this just like you normally would, but it had some issues. First, if we set transfer output files equal to a directory, HTCondor seems to walk through that directory and uploads each file at a time. This can break rsync because you're asking rsync to write to a directory that may not exist yet. For example, we had this directory output. HTCondor found a file in there called file, so it fed output/file to the plugin, which the plugin happily tried to rsync to Gibson as output file, but output didn't exist yet. So it sort of did things out of order. So we got around this by creating a custom attribute called nrao output files, which tells our plugin what files and directories to upload. This basically replaced transfer output files at this point, but it turns out we can't leave transfer output files undefined, because if you do, then the file transfer mechanism uploads all files, not directories, just files that are created since the job started. You might be familiar with this if you've used the file transfer mechanism. This is sort of a default behavior of HTCondor, but it's not what we wanted. We wanted to upload exactly what we wanted to upload. So we had to set transfer output files equal to something. So we ended up setting it to Condor or underbar Condor underbar standard out. This is a file that's created in the scratch area of each job when output is set in the submit description file. I have an example of this at the end of the presentation. A few more issues we ran into. Normally when a job finishes, the file transfer mechanism remaps Condor standard out and Condor standard error to what output and error are set to in the submit description file. But if you're using a plugin, the file transfer mechanism doesn't remap these files. It passes them directly as Condor standard out to the plugin. So it's up to the plugin to remap them. Not that big a deal. We're already writing it in the Python API, so we just had the API contact the schedD to get the values of out and error from the class head, and then we could rsync standard error and standard out to whatever those are set to. Not that big a deal. Next, we had to set not responding timeout equal to some really large value. We set this in the Condor config on the execution points. And this is because it seems that the Condor starter forks the plugin when downloading, but not when uploading. When uploading, it blocks on the plugin. This means that the starter can't talk to the Condor shadow while uploading. And if you have enough data, which we certainly did in our examples, the shadow will see the job as non-responsive after, I think, a default of 3,600 seconds, and it will kill the job. So that's not ideal. So we set it to a day. It's much longer than we needed to, but it was sufficient to get the job working. And finally, Condor chirp, if you're not familiar with it, among other things, it can be used by the running job to write to the Condor log on the access point. This is pretty useful. nraorsync uses chirp for error reporting on download. But since the starter blocks on upload, as we've seen before, and apparently the starter is what handles the chirp calls, the result would be a deadlock. So we don't use Condor chirp on the upload end of the plugin, but we would like to. And as promised, here is the example, putting everything all together. You can see we set output to something. This all looks pretty familiar, I'm sure. Transfer input files. Here's our SSH key that gets transferred first. Then the plugin can get used to transfer anything else that needs to get transferred on input. Transfer output files equal to Condor standard out. Here's where we pretty much replace transfer output files with a couple of directories. And here's where we set the plugin so that all uploads use the nraorsync plugin. This wait IO proxy just turns on chirp. And down here at the bottom is a Git repo. In the Condor examples, Git repo is where I found a transfer plugin example, very helpful. And here is an example, or here is the copy of our plugin, the nraorsync plugin. Short and sweet. Any questions?